Buzzing in a circuit breaker can indicate several issues. Firstly, overload, where excessive current flowing through the breaker causes the contacts to vibrate. Secondly, loose connections, where poor electrical connections can create arcing, which can generate buzzing. Thirdly, a faulty breaker. A damaged or defective breaker may not provide adequate contact, resulting in vibrations. Fourthly, a ground fault. A ground fault can cause current to flow through the ground wire instead of the neutral wire, creating a humming or buzzing sound. However, this usually triggers a trip response from the breaker. Any level of audible buzzing at a breaker should be considered a red flag and requires further evaluation by a licensed electrician. While it may not always indicate an immediate electrical hazard, it suggests an underlying issue that needs to be addressed. Possible causes of ground fault without trip response are high ground impedance. The resistance of the ground path can be too high to trigger the breaker's trip response, even though current is flowing through the ground. Another possible cause is an incipient ground fault. The ground fault may be developing gradually and has not yet reached a level to trip the breaker. Also, the breaker may be defective and not respond to the ground fault even though current is flowing through the ground wire. As a real estate inspector, it is prudent to recommend further evaluation by a licensed electrician in all cases where an individual breaker is buzzing. This is important for safety and to identify potential electrical hazards that could compromise the integrity of the electrical system or building. A deeper dive into each of these potential issues will help to better understand the reasons why a breaker might buzz. Starting with overload, it's important to remember that circuit breakers are designed to protect electrical circuits from damage caused by excessive current. When a circuit is overloaded, it means that more current is flowing through the wires than they are designed to handle. This can happen when too many devices are plugged into a single circuit, or when a device draws an unusually large amount of current. The excess current generates heat, and if the overload is not addressed, it can lead to overheating, insulation damage, and even fires. A circuit breaker's job is to interrupt the current flow before these problems occur. When the current exceeds the breaker's rated capacity, a bimetallic strip or an electromagnet inside the breaker trips, opening the circuit and stopping the flow of electricity. In some cases, the excessive current flowing through the breaker can cause the contacts inside to vibrate, producing a buzzing sound. This buzzing is a warning sign that the circuit is overloaded and needs attention. Next, consider loose connections. Electrical connections are crucial for ensuring a safe and reliable flow of electricity. Over time, connections can loosen due to various factors such as vibration, temperature changes, and corrosion. A loose connection creates resistance to the flow of current, which in turn generates heat. This heat can further degrade the connection, leading to a cycle of increasing resistance and heat. A high resistance to loose connection can also cause arcing, which is the flow of electricity through the air between two conductors. Arcing produces a characteristic buzzing or crackling sound, and it can also generate significant heat and sparks. These sparks can ignite nearby flammable materials, posing a fire hazard. In addition to the fire risk, arcing can damage the conductors and the surrounding insulation, further compromising the safety and reliability of the electrical system. Now let's examine faulty breakers. A circuit breaker is a mechanical device with moving parts, and like any mechanical device, it can fail over time. A faulty breaker may have damaged or worn contacts, a weakened tripping mechanism, or internal corrosion. These defects can prevent the breaker from functioning properly, compromising its ability to protect the circuit from overloads and short circuits. In some cases, a faulty breaker may not provide adequate contact between its internal components, resulting in vibrations and a buzzing sound. A faulty breaker may also fail to trip when it should, allowing excessive current to flow through the circuit and posing a significant safety hazard. Regular inspection and testing of circuit breakers are essential to identify and replace faulty breakers before they cause problems. Moving on to ground faults. A ground fault occurs when current flows through an unintended path to ground. This can happen when a live wire comes into contact with a grounded surface, such as a metal enclosure or a water pipe. In a properly functioning electrical system, current should only flow through the intended circuit path, from the source to the load and back again. The neutral wire provides a return path for the current, and the ground wire provides a safety path in case of a fault. When a ground fault occurs, current flows through the ground wire instead of the neutral wire. This can create a dangerous situation, as the ground wire is not designed to carry large amounts of current. Ground fault circuit interrupters, also known as GFCIs, are designed to detect ground faults and quickly interrupt the current flow. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. While ground faults typically trigger a trip response from the breaker or GFCI, there are situations where a ground fault may occur without causing a trip. One possible reason for this is high ground impedance. Impedance is the total opposition to current flow in an alternating current circuit, and it includes both resistance and reactance. If the resistance of the ground path is too high, it can limit the amount of current that flows through the ground wire. This limited current may not be enough to trigger the breaker's trip response, even though current is flowing through the ground. High ground impedance can be caused by corroded or loose connections in the grounding system, long ground wire runs, or inadequate grounding electrodes. Another possible reason for a ground fault without a trip is an incipient ground fault. An incipient fault is one that is developing gradually over time. In the early stages of a ground fault, the amount of current flowing through the ground wire may be relatively small. This small current may not be enough to trigger the breaker's trip response, but it can still create a potential hazard. Over time, the fault may worsen, leading to a larger ground fault current and eventually causing the breaker to trip. Regular testing of the grounding system and the use of ground fault detection equipment can help to identify incipient ground faults before they become a serious problem. It's also important to consider that the breaker itself may be faulty. A defective breaker may not respond to a ground fault even though current is flowing through the ground wire. This can happen if the breaker's tripping mechanism is damaged or if the breaker is not properly calibrated. Faulty breakers can pose a significant safety hazard, as they may fail to protect the circuit from overloads, short circuits, and ground faults. Regular testing and maintenance of circuit breakers are essential to ensure that they are functioning properly. As a real estate inspector, it's crucial to recognize the potential dangers associated with buzzing breakers. Even if the buzzing is faint or intermittent, it should be considered a red flag and warrants further evaluation by a licensed electrician. A licensed electrician has the expertise and equipment to properly diagnose the cause of the buzzing and recommend appropriate repairs. The electrician will typically start by visually inspecting the breaker and the surrounding wiring. They will look for signs of damage, such as corrosion, discoloration, or loose connections. They may also use a thermal imaging camera to detect hot spots, which can indicate overheating due to loose connections or overloads. Next, the electrician will use a multimeter to measure the voltage and current in the circuit. This can help to identify overloads, short circuits, and ground faults. It may also use a ground fault locator to trace the path of the ground fault current and identify the source of the fault. In some cases, the electrician may need to remove the breaker and inspect it more closely. They may also test the breaker's tripping mechanism to ensure that it is functioning properly. Once the electrician has identified the cause of the buzzing, they can recommend appropriate repairs. This may involve replacing the breaker, tightening loose connections, repairing damaged wiring, or installing additional grounding electrodes. It's important to follow the electrician's recommendations to ensure that the electrical system is safe and reliable. Ignoring a buzzing breaker can lead to more serious problems such as electrical fires, electric shocks, and damage to electrical equipment. By recommending further evaluation by a licensed electrician, you are helping to protect the safety of the building occupants and the integrity of the electrical system. In addition to the technical aspects of buzzing breakers, it's also important to consider the legal and ethical responsibilities of a real estate inspector. As a real estate inspector, you have a duty to identify and report any potential hazards that could affect the safety or value of the property. This includes electrical hazards such as buzzing breakers. Failure to report a buzzing breaker could expose you to liability if someone is injured or property is damaged as a result of the electrical problem. It's also important to be aware of any local codes or regulations that may require specific actions to be taken when electrical hazards are identified. In some jurisdictions, you may be required to report the hazard to the local authorities or to the property owner. As a real estate inspector, it's essential to stay up to date on the latest electrical codes and safety standards. This will help you to identify potential hazards and to provide accurate and reliable information to your clients. You should also consider obtaining additional training and certification in electrical inspection to enhance your knowledge and skills. Remember that your primary responsibility is to protect the safety and well-being of your clients. I recommending further evaluation by a licensed electrician when you encounter a buzzing breaker. You are fulfilling this responsibility in helping to ensure that the property is safe and habitable. To summarize, a buzzing circuit breaker should always be considered a red flag indicating a potential electrical issue that requires further investigation. The buzzing can be caused by several factors, including overloads, loose connections, faulty breakers, or ground faults. While some of these issues may seem minor, they can lead to more serious problems if left unaddressed. As a real estate inspector, it's crucial to recommend further evaluation by a licensed electrician in all cases where a buzzing breaker is detected. This is important for safety and to identify potential electrical hazards that could compromise the integrity of the electrical system or building. The electrician will be able to diagnose the cause of the buzzing and recommend appropriate repairs to ensure that the electrical system is safe and reliable.